Welcome back. In this short video I'm going to go through how to calculate a gyro or magnetic compass error using a star. If you haven't already done so, please watch my earlier video calculating the gyro or magnetic compass error using the sun, as I have explained some of the steps in more detail there. If you haven't already done so, you can download the proforma used in these videos from my website. The link is in the description below. Before we start our calculations, we need to take the bearing of our star. Don't worry if you don't know which star it is, I will explain the use of the star finder in a later video. We also need to note down the exact time we have done this, which will also convert to universal time, and the vessel's position at that time. We're also going to note down the vessel's heading as shown on the ship's gyro and magnetic compasses. For this example, we're using the star Arcturus. It's the 10th of April 2016 and the time is 23:46 and 10 seconds UTC. We are in a position of 25 degrees 50.6 north and 066 degrees 08.6 west. The ship's heading was 132 degrees by gyro compass and 145.5 degrees by magnetic compass. Lastly, our observed bearing of the star was 075 degrees. Now we have to pull out our nautical almanac and turn to the appropriate daily page. As we're doing our calculation for the 10th of April, we find its page in the almanac. On the left-hand page, we have two columns that we require information from. Firstly, we take the Greenwich hour angle for Aries for the hour we require. In this case, 2300, where the value is 184 degrees and 36.0 minutes. We enter this into the first GHA box on our proforma. Next, we take the sidereal hour angle, or SHA for short, and the declination value for the star that we are using, in this case Arcturus, and we enter the values into the respective boxes on our proforma. Now we turn to the yellow coloured pages in the Nautical Almanac, which are titled Increments and Corrections. They're located near the back of the 2016 Admiralty Nautical Almanac, and these provide the corrections we need to make because our calculation is not being done exactly on the hour. First we find the 46-minute page, and then from the table we read off the correction for Aries at 10 seconds. In this case 11 degrees 34.4 minutes, and we enter this into the increment box labelled Ink on our proforma. As we're working with a star, there are no additional corrections for declination, so we can fill the final declination in as north 19 degrees 05.9 minutes. We now add the initial GHA, our SHA and increment together and enter the value in the second GHA box, in this case 342 degrees 04.1 minutes. This is the GHA of Arcturus on the prime meridian at the given time. As we're not on the prime meridian, we have to correct for our longitude. As we're in a position west of the prime meridian, we subtract the longitude from the Greenwich hour angle, giving us a local hour angle of 275 degrees 55.5 minutes. We'll now use the same formula we used in the earlier videos to calculate the azimuth. So when we type this into our calculator, it gives us the answer of 74.99. We convert this into a quadrantal using the little table on the right. As our LHA is between 180 and 360, and our azimuth is positive, we name it north 74.99 east, which we then convert to a true bearing. As it's the northeast quadrant, we add it to 0, which gives us a true bearing of 075 degrees. You'll notice I have rounded the .99 up. Now we can work out our gyro error just like we did before. Earlier we said we had taken the bearing of Arcturus and it was 075 degrees. We calculated that the true bearing of the star was 075 degrees, so we enter that in the appropriate box on our proforma. When we subtract the gyro bearing from the true bearing, we get 0 degrees, so our gyro error is 0. Now we can work out our magnetic compass error and deviation. Remember we noted the ship's gyro and magnetic compass heading at the time of taking the error. Now we work out the ship's true heading, so we take the ship's gyro heading and add or subtract the gyro error. In this case the gyro error was 0, so our true heading is the same as the gyro heading. Now we know the magnetic heading was 145.5 degrees, so we can subtract this from our true heading, which gives us an error of negative 13.5. As it's negative, we consider it as being 13.5 west. The variation we obtain from the nautical chart or our ecdist system for the current ship's position, which in this case is 13.7 west. As it's west, we consider it as a negative value, so we can do negative 13.5 minus negative 13.7, which gives us 0.2 degrees. As it's positive, we say it's east, so the magnetic compass deviation on our current heading is 0.2 degrees east. Thanks for watching. If you found this video useful, please click the like button. Make sure you hit subscribe to get notified when I post my next video, how to calculate the compass error from a planet.